Good morning to you all once more. In this video, we are going to be looking at statistics. This is the second week's lesson. And at the end of this lesson, learners should be able to, one, compute the mean, median, and mode of discrete data. Two, calculate the range, mean deviation, variance, and standard deviation of discrete data. Then construct a grouped frequency table to include class interval, class mid-mark, frequency, class boundary, and class size. All right. Let's begin the class proper. So the meaning and what's the meaning and computation of mean of ungrouped data? The mean, median, and mode are called measures of central tendency or measures of location. All right. The mean is also known as the average. The median is the middle number, while the mode is the most frequent element or data. A very brief addition to this meaning, you should know that the mean, median, and mode of any evenly distributed data is always coming to the center. A very good evenly distributed data will always have the mean equal to the median and equal to the mode, provided that data, when you sketch the curve, the normal curve, the curve will give you a perfect normal curve. Any data of that nature we have, the mean, median, and mode will all be equal, and they will all be centralized. That's why it's called measures of central tendency. Trying to look at the middle, the number. What is the middle? How can I make a conclusion from a given set of data, seeing the middle? All right. So that's why it's called measures of central tendency. Okay. Arithmetic mean. So there are various types of mean, but the only one we are going to be focusing on in this lesson is arithmetic mean. There is geometric mean, there is harmonic mean, and there is assumed mean. But our interest here is arithmetic mean. So arithmetic mean is the sum of a collection or set of numbers divided by the count of numbers in the collection or set. The mean of an ungrouped data can be calculated using the formula. So here's the formula for the mean of an ungrouped data. And now, please mind you, this symbol X bar is the symbol to denote mean of the data. So this formula is valid when n is small. This is something less than 30. So where the symbol sigma, this symbol sigma x is called, this symbol without x, the symbol zig is called sigma, meaning summation of all given sets. So also, the mean can also be computed using this formula. X bar equals sigma f of x over sigma f, where n is large. So this is when we have a large n, a large given set of data or data set, or we have data sets with frequencies. So we use this particular formula. So in this case, f of summation f of x is the sum of the product of scores and their corresponding frequencies, while summation f is the sum of the frequencies. All right, so let's look at an example to apply what we've been talking about. So first, example 1. Find the arithmetic mean of the numbers 42, 50, 59, 38, 41, 86, and 56. So here's the solution. Very simple, because this is a small n, that is a small given set of number. We apply the first formula, this particular one. Okay, so we sum the whole data set, 42 plus 51 plus 59 plus 38 plus 41 plus 86 plus 56 over 7. Why over 7? Let's count the data set. 1, 2, 3, 4, 5, 6, 7. So we divide it by 7 because we have 7 data in the data set. So, and the summation, the numerator will give 378 over 7, which is equal to 54. 54, that is the arithmetic means, so x bar. Number 2, the table below gives the frequency distribution of marks obtained by some students in a scholarship examination. So here's the scores, or here are the scores. So 15, 25, 35, 45, 55, 65, 75. And these are the frequencies. So frequencies mean how many of the students got this score 15. 1. 4 students got 25 as their score. 12 students got 35, 24, 45, 18, 55, 8, 65, and 3 students got excellent, 75%. So now the question is, calculate correct 3 significant figures, the mean mark of the distribution. So here is the solution. Solution, we create a table, we form a new table for the given distribution. Now, in our table, starting with the scores and the frequency. So here are the scores arranged in ascending order, and the frequencies follows. Then we compute the product of the frequency times the score, class mark. So 15 times 1, 25 times 4, that will give this 35 times 12, 45 times 24, 55 times 18, 65 times 8, 75 times 3. Then according to the formula, which is this summation x bar, the mean x bar equals summation fx over summation f. You need to take the sum of all of this. So when you add up all this, you get this figure. And when you add up the frequency, you get this figure. So we divide the frequency, divide the summation of f of x by the summation of the frequency. And that will give us 47.9 to 3 significant figures. Okay, alternatively, you can solve it using this procedure, but this I would not advise you to do this. You can only do this when the data is the data set is very small, but there are frequencies. You can do this. But if you have a large data set, for reduction of error sake, I will always advise you to rely on the table method. So you can also do the same thing you've done on the table, but do it just uh, on a straight line, or make it fractional and solve. You see arrive at the same answer. Example 3. The table below shows the scores of some students in a quiz. Here are the scores: 1, 2, 3, 4, 5, 6, and the frequencies are given as follows. But notice this: the frequency of those who scored 4 is unknown, x. So if the mean score is 3.5, we are given the mean score. Calculate the value of x. So how many students scored 4? That is the question. Solution. We still go back to our table. Here are the scores, and here are the frequencies. So this is the product of the scores and frequency. Then you take the sum. When you add 1 plus 8 plus 15 plus 10 plus 12, then everything will give 46, then plus 4x. So that is the sum. Then also sum up these values and apply the formula. When we apply the formula, of course, if the mean is known, that is 3.5. 3.5 equals this, then divide and cross multiply. You get 3.5 times 14 plus x equals to 46 plus 4x. 3.5 is something as 7 over 2 into 14 plus x equals 46 plus 4x. And divide or multiply through by 2. Or multiply this side by 2 and multiply this other side by 2. You get the next step. So 2, we factor out 2. So 7 times 14 plus s equals 2 times this. And when you open up a bracket, 7 times 14, 98 plus 7x. 7 times x, 7x plus 2 times 46, 72 plus 2 times 4x is 8x. And that will give us 40, collecting like terms, we have 98 minus 72 equals 8x minus 7x. So 98 minus 72 is equals 6. And 8x minus 7x is equal to x. All right, sorry, 98 minus 72 is equal to 26, and this is x. So the value, what is it called again? The frequency, number of students who scored 4 is 26 students scored 4. Okay. All right. So example 4. The table below shows the mark distribution of an English examination test in which the mean mark is 3. Find the value of y. So here are the marks 1, 2, 3, 4, 5, and the frequencies y3, y plus 3, 3, y minus 4. Then we'll see, go back and apply our method, get the table x, f of x. Take the products, 1 times y, y, 2 times 3, 6, 3 times this, 3y minus plus 9, 4 times 3, 12, 5 times 4 minus y, 20 minus 5y. Take the summation of all of these, and that will give this. Take the summation of the f's, you get this. So apply the formula. So here's the formula: x bar equals summation f of x by summation f, but our mean is given as 3. So substitute and cross multiply again. When you cross multiply, this will give us 3 times 13 plus y equals 47 times minus y. So this is 39 plus 3y equals 47 minus y. 3y plus y equals 47 minus 39, collecting like terms. So y is equal to 2 finally. All right, so at this junction, I'm going to pause. I would like you to pause the video for a while and attempt this class activity 1. The table below shows the frequency distribution of marks obtained by a student or by a group of students in the test. If the mean score is 5, calculate the value of x. So you have 3 minutes to attempt these questions and post your answers. After 3 minutes, I'm going to check your answers. Then you can continue watching the video. Next, I want to talk about the meaning and the computation of median and ungrouped data. Median of ungrouped data. So the median is the value of the middle item when the items are arranged in order of magnitude, either ascending or descending order. So here is example 1. Find the median of the following set of numbers: 16, 13, 10, 23, 36, 9, 8, 48, 24. This is the solution. So first, we arrange the numbers either in ascending or descending order. So I've decided to arrange here the numbers in ascending order. And when you count, let's count 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 data sets here, or data. Let's divide it into 1, 2, 3, 4, 1, 2, 3, 4. So the middle number here is 16. Okay, that means the median is 16. Very easy to find. Very, very easy. Now, how do you solve or calculate or find the median for frequency distribution with large N, that is large data set? So there are 2 valid formulas. 1, the median is given by this: n plus 1 over 2. That is the n plus 1 over 2, 10, when n is odd. And when n is even, the formula becomes n over 2, 10 plus n plus 1 over 2, 10 over all over 2. So these are the 2 valid formulas. When the n is odd, meaning any number that is not divisible by 2, this formula is valid to locating or calculating the median 10. While if the n is given is even, then the second formula here is valid. So let's see a practical example on how to apply those formulas. Example 2. The table below shows the distribution of marks scored by some students in a math test. Marks: 22, 24, 36, 42, 45, 48, 56, 60. The frequencies are given as follows. So solution. Now, in this particular instance, to find the median, we get the table, of course, get our frequency distribution table. Next, we compute the cumulative frequency. So what is cumulative frequency? It is adding up the frequencies cumulatively. Adding it cumulatively, you cumulate it. You keep adding, add the next to the initial or to the previous, add the next to the previous, keep adding. So here is it. So you start with it by writing the first frequency, 11. Next, you add 2. to 11 to give you the next cumulative frequency, 13. Next, you add 7 to 13 to give you the next cumulative frequency, that is 7 plus 13, 20. Add 13 to 20, that will give 33. Add 10 to 33, and that will give 43. Add 3 to 43, and that will give 46. Add 9 to 46, and you get 55. Finally, add 5 to 55, and that will be equal to 60. Now, how do you check if your cumulative frequency is computed correctly? It will always be equal to the total frequency. So you add up these frequencies, add it up. When you add up, you are expected to get 60 in total. And if the value is not 60, meaning our cumulative frequency is not computed correctly, or maybe we have done some mistake in calculating the frequencies. But having said that, so say from the table, there are 60 members as indicated in the cumulative frequency. So in this case, our n is what? Our n is even. 60 is an even number. So we're going to apply this formula. Now this is the application. So since n is even, we apply the formula. Okay, let's go ahead and apply. Since n is even, 60 over 2 is 60 over 2. All right, so we have okay, so when you substitute 60 over 2, 10 plus 60 over 2 plus 1, 10. That is the 30th and the 31st term over 2. And let's go back to our cumulative frequency to see what the 30th and the 31st term are respectively. So the 30th term is 42% and the 31st term is 42% also. All right. So you add the 42nd plus 42nd term over 2, and that is 84 over 2. That is the 42nd term. The median is the 42nd term. So that is this term here. All right. So how do we know the 30th and the 31st term are both 42nd term? So you can see it here. When I check the cumulative frequency, this is 33. So both the 30th and the 31st are in this cumulative frequency region. All right, so I hope that explanation was clear enough. Okay, finally, question number 3, example 3. Calculate the median age from the following data. So here is a given table, and let's look at the solution. Getting our distribution table, these are the ages, number of students, and cumulative frequency. We add up again, just like the initial example. We get the cumulative frequency. And in this case, our n is odd, 71. Apply the first formula, 71 plus 1 over 2 member, and that is 72 over 2, that is the 36th member. Where will the 36th member lie? Let's check. It's going to lie here. Let's trace it to the years. So that is 14 years. So the 36th member is 4. That means the median here is 14 years. Do you see that? The 36th member falls within the cumulative frequency of up to 40, and this is under 14 years. All right, so this is a second class activity. You are meant to calculate the median of the distribution below. Calculate the median of the distribution below. I'm going to pause. I'm going to end the video at this point and continue again in the next video. Thank you very much. Please, I would like to receive the solutions. Remember how we do it. Solve handwriting, your exercise note, your exercise book. Write your name on it, snap and upload. Thank you.